Hello everyone, welcome to Tech-Lavya. Please like, share and subscribe.
Now the topic for today's lecture is we are going to solve few numericals based on three-phase voltages. These types of numericals are very important for our exams. Okay, so we shall go ahead and let us see what first numerical says. Now the first numerical for today's class says that 350 ohm resistors are connected in star across a 400 volt three-phase supply. Okay, fine. So first what we will do is we will draw a three-phase supply with 350 ohms resistors connected in star fashion. Okay, so this is how it is to be drawn. This is 50 and balance load, correct? We know that the load has to be balanced. We are talking about a balanced system, right? Yes. So this is how the diagram looks like. Okay. And it says that it is connected across a 400 volt three-phase supply. It means that the line voltage is 400 volts. Okay. Okay. Now what is going to be the phase voltage in this? Phase voltage is the voltage induced across each winding, right? So we have to take with respect to neutral. So this point is neutral. So this is my phase voltage. Okay. Then it says that find the current. Which current? Phase current. Then line current and the power taken from the mains. Okay. So we have to find out phase current, line current and the power. Then it says that what would be these values if one of the resistors is disconnected. Okay, so that we shall discuss, after some time. So let us divide the whole numerical problem or statement into two parts. Okay, let us say that this portion is part 2. Fine. So what we will be doing is now we will be dealing with part 1, wherein the circuit diagram or the diagram is shown in the figure. Fine. Let me specify that the connection is star connection. Now I know in star connection the relationship between the phase voltage and line voltage is given by this. Correct? Yes? Or actually the equation was VL is equal to root 3 times phase voltage or line voltage was root 3 times the phase voltage. So from that we calculated the phase voltage which is equal to line voltage upon root 3. Now what is the line voltage? 400 volts divided by root 3. So the very first thing we get is the phase voltage, which becomes equal to, when we divide it by the square root of 3, the phase voltage comes out to be 230.94 volts. Okay, fine. Actually they did not ask us to calculate phase voltage, but we require it. Now why do we require it? Because they have asked us to calculate phase current. And how will we calculate the phase current? Come on. That is again given by Ohm's law only. So it is the phase voltage upon the phase impedance. Fine. Now this circuit which is there in the problem statement is a pure resistive circuit, right? So this is a pure resistive circuit. It means it has resistive load. Fine. So what is the phase voltage now? It is 230.94. What is the impedance? 50 ohms. Okay. So when I divide 230.94 by 50, I get the phase current to be 4.62 amperes. Fine. So this is my the first answer actually. Now comes line current. Okay. So in star connection, what is the relationship between the phase current and line current? They are same. Okay, the phase voltage and line voltages are not same, but line current and phase voltages are same in case of star connection. Fine. It means that my line current is also 4.62 amperes. Fine. So I got this as well. Okay. Now we shall talk about the third thing, that is the power. Now what is the power in case of three-phase circuit? The power in three-phase circuit is given by root 3 VL IL cos phi. Now what is this phi? Phi is the phase angle, but in this case phase angle is going to be 0 degree. Why? Because the load is resistive load. Fine. Okay. So I shall place the value. Power P is equal to square root 3. Line voltage was 400. Line current was 4.62. And I shall put phi as 0. So it becomes root 3 into 400 into 4.62 into what is the value of cos 0? 1. So in this case, the power comes out to be 3200 watts. Okay, or 3200 watts. So this is my answer. Understood? So this was quite simple. Yes. So now we shall go to part 2. For this, I shall erase this. Now, what is part 2? What is part 2? It says that what happens when one of the resistor is disconnected. So what we will assume is we will disconnect one of the resistors. So let us assume that this resistor is disconnected. Fine. All other things remain the same. So this is 50 ohms, even this is 50 ohms. This is one phase, this is second phase, and here we have the open circuit. Line voltage remains the same. But now if you notice, now this is no more a star connection. Okay, this is now no more a star connection. Now which type of connection is this? If I draw it, without all other terminals, I'll try to simplify it in order to show it to you. Yes. Now this is a connection, isn't it? All other terminals do not matter because now the remaining circuit is open. So now this is 50 and now this is also 50. So which type of connection is this? That's right. This is a series connection. So what is the impedance? 50 plus 50, which is equal to 100 ohms. Got it? Yes? Very good. Now I shall write here part 2. Okay? Now what will be my phase current? Phase current and line current both are same. Correct? So it is going to be the total voltage upon the total resistance, which is 50 plus 50. So the answer comes out to be the phase current or line current, they are same and the value is 4 amperes. Okay. Now what is the next thing? Next thing is the power in this case. Okay. Now what is going to be the power? What is going to be the power now? Is it going to be root 3? Is it going to be root 3? Because now we do not have 3-phase. Now we are talking about this line voltage only. Correct? Yes? Otherwise this particular circuit is now gone. So now this is a simple circuit. Correct? So power is going to be now VL IL cos phi. Again this is a resistive circuit. So I shall say that phi is 0 because it is a resistive circuit. So in turn the value of cos phi becomes 1. So my power becomes 400 into 4 into 1. So in this case the power comes out to be 1600 watts. Okay. Now if you compare both the values, earlier the power was 3200 watts and now in this case it is 1600 watt. It means the power is halved. So I can say that by disconnecting one of the resistors, the power becomes, or the power is halved. Okay, fine. Yes. So now let us go to the next type of numerical. Now the next numerical says that in a balanced 3-phase circuit, the power is measured by 2 wattmeter. Okay, it means this is the numerical from power measurement and we are using 2 wattmeter method. Fine. Then it says the ratio of 2 wattmeter reading is 2:1. Okay. Determine the power factor. Fine. So first of all, what is Now what is the power factor? Power factor is cos phi. Correct? And then with 2 wattmeter method, phi is given by. What is the value of phi? It is tan inverse. We have seen this, right? It is tan inverse in bracket square root 3 W1 minus W2 upon W1 plus W2. Correct? Yes. So this is the phase angle equation. So we shall first find out what is phi and then we will be putting the phi value in cos phi and then we'll be getting the power factor. Now remember, here I have written W1 minus W2. Okay? But basically it is like whatever is higher that comes first and lower reading is subtracted. So you cannot get a minus value here. It can be W1 minus W2 when W1 is greater than W2, or it can be W2 minus W1 if W2 is greater than W1. Okay? Fine. But now we don't know what is W1 and W2. But what is there, what is given in the numerical, it says that the ratio of 2 wattmeter readings is 2:1. So whenever it is specified that ratio of 2 wattmeter reading, it means W2 by W1 is specified. And that ratio is specified to be 2:1. Correct? 2:1. So with this, I can say, after cross multiplication, I can say that W2 is twice W1. Right? It means that W2 is greater than W1. Isn't it? Yes. So which equation I have to use between these two? I have to use this. So what I'll do is, this is a standard, please remember that this is a standard equation. I'm telling you how to write the proper equation for that particular numerical. Fine. So here I will say that in this numerical, W2 is more and hence the equation becomes this. Okay. Yes. So what we will do is, we will put the values. Fine. What we will do here, I shall erase this so that we can get some space. Yes. So here I shall erase this as well, and I will write it here. W2 is twice W1. So now phi becomes tan inverse root 3 2W1 minus W1. I'll be putting the value of W2. Okay. W1 plus 2W1. After putting the values, we get this. So phi comes out to be tan inverse root 3. Yes. The 2W1 minus W1 is W1 upon W1 plus 2W1, 3W1. These two get cancelled, and root 3 also gets cancelled with 3. So here we get phi to be tan inverse 1 by root 3. Okay. So for what value of angle do we have? For what value of angle do we have the tan theta to be 1 by 3? It is 30 degrees. Fine. So phi comes out to be 30. Now we shall calculate power factor. What is power factor? Cos phi. So cos 30. Fine. So in turn I get power factor, which is cos phi, and cos 30 value comes out to be 0.866. Okay. So this is the answer. Fine. I hope you understood. So with this we end today's lecture. Thank you.